Let's talk about microservices, one of the most popular and talked about architectural styles of our time, which offers a template for developing software applications as suites of independently deployable small services, each running in its own process and communicating with each other via network through simple interfaces and lightweight mechanisms like HTTP or REST API. And this is what the classic definition of microservices is by the Martin Fowler. It is said that this approach is traditionally based on the philosophy of Unix that says one program should fulfill only one task. Programs should be able to work together, and a universal interface should be used. So, in one line definition of microservices, we can say microservices are small, autonomous services that work together. But the question comes, why and when do we need microservices? So, basically, when you have the processes that need to communicate over a network, there are a few different ways of arranging that communication. The most common arrangement is to have two roles, clients and servers. The servers expose an API over the network, and the clients can connect to the servers to make requests to that API. The API exposed by the server is known as a service. But the web browser, as we know, are not the only type of client there. For example, a native app running on a mobile device or a desktop computer can also make network requests to a server. And a client side JavaScript application running inside a web browser can use XML HTTP requests to become an HTTP client. This is what we call the AJAX. In this case, the server's response is typically not HTML for displaying to a human. Moreover, a server can itself be a client to another service. For example, a typical web app server acts as client to a database. This approach is often used to decompose a large application into smaller services by area of functionality, such that one service makes a request to another when it requires some functionality or data from the other service. And this way of building application has traditionally been called the service oriented architecture, SOA, which is, we can say that more recently refined and rebranded as microservices architecture. So basically, we need SOA or microservices architecture when we have services to offer through web. And then those services should be independently deployable, yet capable of communicating with each other. In some ways, there are some commonalities between services and databases, we can say. They both allow clients to submit and query the data. But however, while databases allow arbitrary queries using the query languages, services exposes an application specific API that only allows inputs and outputs that are predetermined by the business logic, the application code of the service. And this restriction provides a degree of encapsulation. Services can impose fine grained restrictions on what clients can and cannot do. Now, the question is, what could be and what are the common design goals of microservices? A key design goal of service oriented architecture or microservices architecture is to make the application easier to change and maintain by making services independently deployable and evolvable. For example, each service should be owned by one team, and that team should be able to release new versions of the service frequently without having to coordinate with other teams. So, some typical use cases can be, let's say, for website migration, where a complex website hosted on a monolithic platform needs to be migrated to a cloud based and container based microservices platform. Or for media content, we are using microservices, media assets like Images and videos can be stored in a scalable object storage system and served directly to web or mobile apps, or for transactions and invoices related apps, where payment processing and ordering can be separated as independent units of services. And for data processing kind of scenarios too, where microservices platform can extend cloud support for existing modular data processing services. And there can be other such kind of use cases where microservices architectural approach can really help. In his book, Microservices Flexible Software Architecture, Eberhard Wolf has more accurately summarized it when he said that at a very preliminary level, one can say, at a very basic level, one can say that microservices are a modularization concept, as their purpose is to divide the large software system into the smaller parts. Thus, they influence the organization and development of software systems. And we know the growing focus on the microservices have promoted the culture of DevOps and DevSecOps too. Microservices can be deployed independently of each other. Changes to one microservice can be taken into production independently of changes to the other microservices, of course, using the CI/CD practices. Microservices can be implemented in different technologies. There is no restriction on the programming language or the platform for each microservice. Microservices can be implemented with a host of frameworks and versions and tools, whether it's Java, Python, C++, Node.js, and .NET. Microservices possess their own data storage, a private database or a completely separate schema in a shared database. Microservices, we can say, are the self contained processes of virtual machines, and they can bring their own support services along. For example, a search engine or a specific database. And finally, we can say that microservices have to communicate via the network. To do so, microservices use the protocols that support the loose coupling like REST or messaging. So, in a nutshell, we can finally conclude that at a very basic level, this is what the microservices are all about. And microservices belongs to the next generation software development technology toolkit that helps in improving processes and software quality across each stage of the software development. To highlight the benefits of microservices, they are often compared with the monolithic architecture, which I believe is not a right way to start with, as each architectural style or pattern has its own use cases, benefits, strengths, and weaknesses, and trade offs as well. And which one to pick, which one to choose for your current project, depends on a number of factors that are not necessarily technical.